A few years ago, FPV drones were just a hobby or way to get aerial shots. Today, they are one of the most deadly weapons on the battlefield, and with every year or even month, they are becoming more and more sophisticated. Today I will tell you how these drones are designed, who creates and operates them, why an FPV drone worth a couple of $100s can destroy military equipment worth millions, and of course, we will discuss the technological contributions they have made to the world of FPV. A couple of years ago, if you had googled military FPV drone, you would have seen expensive, difficult to operate and quite large fixed-wing aircrafts. However, after the start of the war in Ukraine, military engineers came up with an incredibly simple but yet effective idea that was just begging to be used. What if we take a regular civilian FPV drone and attach an RPG warhead to it? After all, such drones will be tens if not hundreds of times cheaper than fixed wings. Sure, they might be a little slower, but they are better in terms of accuracy and maneuverability. They are harder for radars to spot due to their low altitude flight, and additionally, unlike fixed wings, they can hover in sky waiting for the perfect moment to strike. This is why the idea was implemented quite quickly. At first, they were just regular FPV quadcopters with an attached RPG shell. However, even this was enough to change the war zone forever. Now there is no point in grouping up, and it doesn't matter if you are standing still or moving in a vehicle. A drone can arrive at any moment and you won't be able to run or drive away from it. Since then, drones have been actively improved. The most significant upgrade of the last year has been fiber optics, which has made electronic warfare systems useless. But before we discuss such details, let's trace the path of a military FPV drone from the start of its assembly to its realization to understand the basics of this technology. So, FPV drones are assembled either by specialized organizations or by the most ordinary volunteer centers. You don't need any special knowledge for this, you just need to know which wire to solder where. It's like an adult construction kit. For those who have never built an FPV drone, here's a brief rundown of what parts it consists of. The frame is a foundation to which all parts are attached. Current military FPV drones already use quite large frames, which in civilian drones are used for long-range models. Next, we have flight controller and ESC. The first is, roughly speaking, the brain of the drone, while the second transmits information from the FC to the motors and regulates their rotation during flight. Accordingly, the motors are soldered to the ESC and mounted on the arms of the frame. Then we need a camera and a transmitter with its antenna. In most cases, they use analog VTX, just like old TVs. Yeah, the picture from it isn't as sharp as digital, but it's much cheaper and the latency is lower. Also, digital video systems are easier to jam because they use two-way data transmission, from the goggles to the drone and from the drone to the goggles. You will understand why this is so important when I will talk about EW systems. Next, we have a receiver with antenna for direct control from the remote. And the final components are the propellers, which are typically three-bladed props, offering the best balance between speed and efficiency. At this point, our still civilian FPV drone is ready. Next, it's sent directly to the front line, to the team that will deploy these drones. They are the ones who turned these originally civilian drones into a weapon, attaching an RPG warhead or another charge to it and connecting an initiator that guarantees the charge will explode upon impact. In the early days of FPV drone use, without an initiator, there were cases when the drone reached the target but the charge didn't detonate. There are several types of initiators. You have probably seen some wires in front of the drone's camera. Yes, that's an initiator. A short circuit in the wires causes the projectile to detonate. There are also small boxes that detect when a collision occurs and send an electronical signal to the munitions detonator. And of course, there are pins. They are attached to the front of the drone and also detonate the projectile upon a precise hit. A battery is also attached to the drone only after it arrives to the battlefield. While at the beginning of Kamikaze drone use, ordinary LiPo batteries, which are standard for civilian drones, were used. They have since been replaced by Li-ion 18650 batteries soldered together. They have a greater capacity and can provide longer flight time, which is exactly what these drones need. The minimum number of people who conduct operations is 2. The pilot, who must be able to fly well enough as the success of the operation mostly depends on them, and the engineer, who handles the technical side of the drones and coordinates during operations. However, often there are a few more people with them. For example, a driver, who transports the crew either to the basement of an abandoned house or to dugouts, from which they will directly conduct operations. On the ground above them, they set up an antenna for better signal and a structure built for the drone launch. Most often these are PVC pipes fastened together or even two stools, which help the drone to stand vertically even if a rounded projectile is attached underneath. And when intelligence information about the enemy's location comes in, the engineer connects the drone, places it on the launch structure, and the pilot arms it and takes off. What matters most is that the weather conditions are suitable. This is one of the biggest drawbacks of FPV quadcopters. They are very sensitive to the weather. A simple rain can short-circuit the electronics. Fog won't let you to see anything through the goggles, and even a slightly stronger wind can cause the drone to crash where it wasn't intended. But let's imagine it's a beautiful sunny day, and the drone is already in the air. It seems like it will complete its mission in just a few minutes. However, this is where the electronic warfare systems come into play. They try to jam both the video feed and the drone's control. The main thing is to guess the correct radio wave frequency, and while pilots actively change frequencies and use various technologies for noise immunity, EW systems are still capable of interfering with the signals. Many mistakenly think that to cut off the drone's video link, you need to direct the jamming towards the drone itself. In the case of digital transmission systems, this can work because they require an additional channel from the goggles to the drone. Therefore, by aiming the jammer at the drone, you'll block the data packet it receives from the goggles. However, in the case of an analog system, only the transmission of radio signals from the drone to the goggles is necessary. So the radio signals from the EW needs to be directed at the goggles themselves to overpower the weak signal from the drone. There are also jammer guns, but they are only used to take down one specific drone. Their power is not enough to cover the entire sky overhead. However, there is something that will help to ensure no EW system can jam your drone. You have probably seen videos from the battlefields where the drones left some kind of strange and unpleasant spider web. It's probably the simplest but the most interesting technology integrated in the drones: fiber optics. I already mentioned this technology in my last video about all types of drones, but let's take a more detailed look at how exactly it works. A special spool with an integrated media converter is mounted on the drone. As the drone flies, it converts the electronic signals into light pulses, which are transmitted through the unspooling fiber optic cable, while a second media converter at the cable's base feeds this data into the receiver, which is conventionally linked to the remote and goggles. The connection is bidirectional, so the signals traveling from the pilot to the drone follow the identical process, just using a different light wavelength to ensure the simultaneous flow of both command and telemetry data through the single fiber optic cable. However, as strange as it may seem, fiber optic drones have a shorter flight distance than the drones without this technology. This is because the fiber optic spool weighs quite a lot, thereby increasing the load on the motors, which in turn drains the battery faster. Currently, the standard spool for fiber optic drones has 5 km long cable. Of course, you can install a 10 km spool, but in that case, you will have to reduce the payload weight, and instead of an RPG warhead, use some kind of grenade, which could only be used against infantry or motorized troops. Fiber optics also solves another quite important issue. The video signal from such drones cannot be intercepted, unlike regular drones, where even a child can intercept a video and consequently find out the launch location. In such cases, if the enemy already knows the location, the drone launches are stopped. The crew wait for darkness and relocate. And while drones with night vision cameras are quite common, the darkness significantly reduces the number of FPV drones in the sky. But although the spool is located on the drone, which means if the cable gets caught on the tree, it will continue to unspool from the drone. But if there is a sharp object in the cable's path, the connection will be cut off immediately, because fiber optics is a quite fragile material, and this weakness is already being used. Soldiers place sharp rotating fences to cut the cable. But let's go back to our operation and imagine that we're very lucky and the enemy doesn't have active EW systems today. In the distance, you see a vehicle, but as you fly closer to the road, you realize that there is some kind of mesh tunnel between the drone and the vehicle. This is so-called tunnel of life, which is intended to stop the drone from a direct hit on a military transport in open areas. However, almost always there are spots in such structures that an experienced pilot can fly through quite easily. So now you're inside this tunnel, but the vehicle you want to hit is equipped with some strange iron structures. The military calls this a grill, and as you can guess, it's supposed to prevent serious damage to the equipment from a drone hit. And now you decide to push the throttle stick all the way up and crash into the vehicle at full speed, after which all you see in your FPV goggles is just noise. Whether you manage to inflict significant damage with the drone is unknown. You can only find it out if someone from your crew was flying a DJI drone and captured what happened after the impact. This is how present-day FPV drone operations work in the war. And although I did deep research on this topic using multiple languages, I'm still not a military expert. So if I missed anything, please let me know in the comments. Finally, let's talk about the future technologies that are already being tested. For example, Mother Drone. This is a large fixed wing with attached Kamikaze drones. During flights, it gets closer to enemy positions and releases the FPV drones, which are then taken over by the pilot. This gives more time for precise strikes, as the FPV drone doesn't need to cover a great distance to reach the target. Another interesting technology is the remote control, and we're not talking about just a few miles. It's about thousands of miles. Imagine a pilot controlling a drone in a combat zone while being located practically anywhere in the world. There are no technical details yet on how exactly this system works, but it's being tested and everyone understands the possibilities it creates not only in the military, but also in the world of civilian drones. And of course, I have to mention AI. It's already being used in some fixed-wing drones, for example to dodge air defense. However, there is no stable AI technology in FPV drones yet, because it requires quite powerful computer hardware installed on the drone. But let's be honest, we all understand that it's only a matter of time. A few years ago, we dreamed of drones delivering pizza. Now, they deliver death. If you gained some new information from this video, I would appreciate your subscription. Bye.